Hello, Melinda. Okay, so this is an explanation of the gel electrophoresis lab. And I'm going to slow down so you can follow along. All right, so you ran the gel, you loaded the gel with the different DNA samples, right? I think you said you were here for that. So what we did is we took a look at the gels. I had stained them, and then we looked at the gels on a light box the next day. And here's what we saw. There we go. So what you're looking at is in this first one right here. There you go. That well number 1, that was our marker DNA. So you're going to see a bunch of lines. There you go. Get it even closer for you. There you go. So you see a bunch of places where the DNA was stained. And then in well number 2, I believe that was the cystic fibrosis known banding pattern. In lane 3, you have a wild type. That's somebody who's normal. In lane 5, let's see, this one right here. That one. You have child number 2. And in the last one over here, that one, oops, that one, you have child number 1. So child number 1 matches the banding pattern of the cystic fibrosis, which is right there. Cystic fibrosis is right there with the 2 little banding patterns. And so there you go. It tells you exactly what's where. Boom. All right, so then what we did is we measured the distance that each band traveled from the starting point, from the well. When we used centimeters, we used a ruler, and we just took this picture, and then we looked on the gels. The gels pretty much turned out, but there was something goofy going on with them. I think there was a contaminant in the beaker that I used, because there was some stuff floating in there too. So we were able to see them, but not well enough to really distinctly be able to measure them. So we just used, I did a picture, and we just used this, and they measured. Okay, so how far did this band go from here to here? How far did this band go from here, the well, to here? How far did this band go from here to here? How far did that? And that's the distance traveled. So we were going to fill in then this chart on this page right here of your lab manual. And in this first column, we want the distance traveled. So that's where we put our distance in centimeters. And then we put the RF. So what the heck is an RF? If you look up at this equation right here, you're going to put the distance traveled by the band divided by the total distance traveled for the dye to get to the end of the gel, which was the same for each one, and that's 7.5 centimeters. So for each distance traveled, we put that over the top, and then we divided it by 7.5, and that became our RF factor right there. And then we filled those in for each one of these bands that we got right here. So we filled out our little chart, and I'm going to show you the answers. There we go. So here are the answers to that chart. So if you want to do a little pause, make sure that you can read that. I'll hold it really still. There you go. You should have the distance traveled and the RF for the marker DNA. And then what we did with that, don't look at the rest of this yet. What we did with this information is we came over to this page on your lab, this one right here. And this is probably the trickiest part of this whole lab, is to figure out what's the best fit line of known base pair lengths, and then to interpolate our own data. So what's a base pair length? The base pair length is how long is that little piece of DNA so that it would get stuck. The biggest pieces got stuck way back here at the beginning, and the smallest pieces traveled the furthest. So what we're looking for in this actual BP is the actual base pair length. So because it was this first lane right here is a known piece of DNA that was cut up using restriction enzymes. We were able to fill in the known base pair length. So that's just how long it is. How many nucleotides long, how many A's, C's, T's, and G's that actual piece of DNA is to travel this far. So the longest one, the longest base pair length, traveled the shortest distance. And the smallest base pair length was able to go all the way to the end down here. So what we're going to do with your graph then is you have to just take, you've got your base pair lengths here, which are given to you for that first set, that first column, and then we're just going to plot those on here. So what you would do is take the actual base pairs for each one of these, and you plot them on this graph as points, discrete points. So using the RF factor also. So you're going to have both of these numbers. You're going to have base pair length, and you're going to have the RF. And then you just plot those on this graph right here. When you do that, when you finish that, you're going to have something that looks like bada boom, bada bing, this. So let me show you what this is. So you can see the individual points have been plotted, and then a best fit line was drawn. So you had one data point way the heck up here. That's an outlier. And if you've drawn a best fit line before, you'll know you want to discount your outliers. And then we drew a best fit line through all of our data points. Now this becomes our metric for determining what the base pair lengths of are for the other, these guys. So we knew these, but then we had to determine our base pair lengths interpolated. That's what that means when we're going to use this graph to interpolate our base pair lengths based on the best fit line of the known values. So for example, we only care about child 1 and child 2 because the other two were known. So we had known CF mutation, and wild type is somebody who does not have the cystic fibrosis mutation. So those are banding patterns for those two. We're interested in child 1 and child 2. So child 2 is actually in well number 5, and child 1 is in well number 5. So 4 is child number 2, 5 is child number 1, and in 6, well 6, there should be nothing because that was a control, where there shouldn't be any DNA whatsoever. And so how to interpolate that? So we had to measure the distance traveled for child number 2, which is in well 4, and child number 1, which is in well 5, column 5. And then there are the distances that we determined. You can see that, distance traveled. We calculated our RF for each one. And then how did we get this interpolated base pair? We got the interpolated base pair by doing this. My first, for child number 1, the distance traveled, I've got my RF factor right there. And then the RF factor had to be interpolated to get my base pair length. So I would go over to here. My RF for this first one, this first band is 0.43. I calculated that out and I got an RF of 3 or 0.43. Then I come over to here and see at the bottom. The bottom I go to 0.43. I take my ruler and I go straight up to where it hits the best fit line. At the point where it hits the best fit line, I take my ruler, turn it the other way, and so here's my ruler. Take my ruler and I say, oh, okay, it hits the best fit line right there. Now I take my ruler and go straight over to my base pair lengths, and I see that that comes out between 2,000 and 3,000. So I'm going to say, oh, that's about 2,500 base pair lengths, maybe a little bit more, like 2,600. So then I would go back And I would say my interpolated is 2,500 base pair lengths. And I do that for all of those to get my interpolated base pair lengths. So at some point you might have to use, this is called a log 10 logarithmic graph that you used right here. And with all of these in the future, if you were to use it, you would use some known factors. You'd create a best fit line, and then you'd interpolate your own data. It's not necessarily always base pair lengths, but it can be anything in math or statistics. So that's how to do that. I'm going to show you that picture one more time. And that's the red part is where you're interpolating. And the blue line and the dots, those are the known values that we did. So that's how you interpret the data that you got from the gel. All right, you're just taking measurements and looking how far did the band travel from the original place to get those numbers. All right, so hopefully that clears up a little bit of that for you about the results. If you have any questions, shoot me an email, let me know, and I will help you out. I can also help you out in person when we get back face to face or later on the week. So just let me know.